Okay, for number 10, we have 5/6 minus 1/4. Remember, when we're adding or subtracting fractions, we need to have a common denominator. And let me explain the reason for that a little bit. We can't subtract 5/6, or we can't subtract 1/4 from 5/6 because the denominator tells you the size of the piece, the size of the pieces. In other words, if I had a pie and I split it into 6 pieces, I have 5 of these 6 pieces, so I have 5 of these. I can't subtract 1/4 from that because I would be subtracting a piece that's a different size. You could subtract, if you think about it like apples. You could subtract 1 apple from 5 apples, but you can't subtract 1 apple from 5 oranges. You have to be adding or subtracting the same thing. The thing we're subtracting here is the pieces, and they have to be the same size before we can subtract. So the denominator tells you the size of the pieces. The numerator tells you how many you have. I have 5 pieces that are 1/6 large, and I want to subtract 1 piece that's 1/4 large, and I can't do that. So I need to find a common denominator and find the least common multiple of 6 and 4. So think of multiples of 6. 6 times 2 is 12, and that is also a multiple of 4. So I need to change these into 12ths. 5/6 equals how many 12ths? 6 times 2 is 12. So I multiply my numerator times 2, and I get 10 12ths. So I'm rewriting 5/6 as, well, let me just do the other one first. 1/4 equals how many 12ths? 4 times 3 is 12. So multiply the numerator by that same factor, and we get 3 12ths. I'm going to, over here, rewrite this subtraction with my equivalent fractions. 10 12ths is the same as 5/6, and from that I'm subtracting 3 12ths. Now I'm subtracting pieces that have the same size. I'm subtracting 3 12ths from 10 12ths. A 12th is just a thing. It's just a piece that has a certain size. And 10 minus 3 is 7, so I have 7 pieces left that are 1/12 large, and the answer is 7 12ths. The difference is 7 12ths. Okay, problem 11. 4 times 3 and 3/5. We can't multiply fractions. Well, let's remind ourselves of the song that we learned. Dividing fractions is as easy as pie. Just flip the second fraction and multiply. Multiplying fractions, that's no problem. Top times top and bottom times bottom. So if I have a whole number and a mixed number, I don't have just tops and bottoms. I need to express these as improper fractions before I can multiply top times top and bottom times bottom. 4 as an improper fraction is 4 over 1. 4 divided by 1 is still 4, so I haven't changed the value. I've just expressed it as an improper fraction. We're going to multiply that times this mixed number expressed as an improper fraction. 5 times 3 is 15, plus 3 is 18, so we have 18/5. Now I can multiply top times top, bottom times bottom. 4 times 18 is 72. 1 times 5 is 5. And we can't leave it like this. The simplest form would be a mixed number, so 72 divided by 5. There's 1, 5, and 7. 1 times 5 is 5. Subtracting, you get 2. Bring down the 2. There are 4 5s in 22. 4 times 5 is 20. Subtract, we get 2. And then we'll write our mixed number this way. 14 and 2/5. 14 and 2/5. Okay, this next problem, we need to do the same thing. We need to turn 3 into an improper fraction. 3 over 1 divided by 3/4. Remember, dividing fractions is as easy as pie. Just flip the second fraction. That's what I'm going to do right now. Flip 3/4 and make it 4/3 and multiply. So 3 over 1 times 4/3. Now it's top times top, bottom times bottom. 3 times 4 is 12. 1 times 3 is 3. And 12/3, or 12 divided by 3, is just 4. So that quotient, it would be 4. And one other thing I wanted to say about this mixed number, number 11. When we get a remainder, we set up our mixed number this way. When you're dividing, your answer ends up on top of the house. So always start with that number, that's your whole number, and then go around the world clockwise. That makes your fraction 2/5. Okay, that covers all of those skills type problems, and we'll pick up the review with number 13, the last problem in the review, on the next video.